Hi, ladies and gentlemen. We're going to be talking about solubility rules today, and just a reminder to you, soluble, this soluble idea is when something will always dissolve in water, and these are going to be ionic compounds. And when we have a soluble compound, we want to make sure that we always ionize when we have a net ionic equation, and they're going to ask us to write net equations most of the time. So you should have your solubility rules worksheet that I gave you today, or handout that I gave you today. And I'm going to kind of be referring to each class of soluble or versus insoluble things, kind of giving you examples of those. So the first example of what is going to be soluble is if we're going to have anything that is a group 1A metal and a nonmetal. And the nonmetal can be anybody from the nonmetal side of the periodic table, or it can be most of your polyatomics. Those all can be considered nonmetals as well. I'll give you a few examples of these. So if we have like potassium chloride does contain a nonmetal. So if we were writing a net ionic equation, we would have to make sure that we ionize potassium chloride within an ionic equation. I'll give you another example. Somebody like sodium nitrate, again containing a group 1A alkali metal, the sodium ion plus the nitrate ion. And we'll throw one more out there, say lithium phosphate. And this one does contain lithium, group 1A once again. And we have 3 of those for one phosphate ion. So the thing to remember is if you have a group 1A, you're always going to be soluble. Now there's also some other soluble compounds or soluble ions that anytime you see them, the ionic compound is automatically soluble. And so ammonia is one of the real common ones. Anytime you have an ammonia in there, your ammonium ion, you're going to be soluble. Nitrate, anytime you see a nitrate in there, for chlorate, and acetate. If you see any of these guys in a compound, that compound is going to be soluble. Okay? Now let's talk about some of the compounds that are soluble, but they have exceptions to the rule. Okay? And so looking over there at the halogen class, this is group 7A, and we're not looking at fluoride right now, but we could do chloride, bromide, and iodide. These guys are all soluble. The exception is if you put these with silver, the silver ion, the lead 2 ion, or the mercury 1 ion. So silver, mercury, lead make these insoluble. Normally they would be soluble. So a good example of this would be like if you had magnesium chloride. Magnesium chloride, it's a chloride. Chlorides are soluble, so we would break this up into the magnesium ion plus the chloride ion. But if you have silver chloride, this would not break up. So it's going to stay as a solid in solution, straight across. Not going to break up and ionize. So it gives us an example there. Continuing on, another soluble with an exception, that's going to be our sulfate. Sulfate's going to be soluble. Exception, again, is going to be our silver, our lead, and our mercury. Anytime you put those with sulfate, it's going to be insoluble. But we can also add what we call cassava, which is just my shortened thing for calcium, strontium, and barium ions. And you'll hear that cassava come up again as well. Okay, so let's talk about some of our ions that we know are insoluble. And these guys do not dissolve. And you do not ionize in a net ionic equation. There's some exceptions though. So these guys are typically things like carbonate, phosphate, oxalate, chromate, and sulfides. These guys are all, when you see them, they're going to be insoluble. Exceptions to the rule. except if you are a group 1A, or if you're an ammonium ion, that will make those soluble. It'll overcome this rule. Let's talk about a couple of insolubles with exceptions that are really, really important. Hydroxide is typically insoluble. Exception, when, once again, going back to that group 1A. And we're also talking about, for these guys, cassaba, calcium, structure, barium. This is a very, very important group here because these are all what we call strong bases. We'll talk more about these guys in the coming days. Oxides as well, and these guys have the same exact exceptions all the way down, group 1A plus cassaba. Okay? Now, the usage for this is usually for double replacement reactions, also known as precipitation, which we'll abbreviate PPT. So let's flip the page to the next one, and we'll give you an example of what you're going to be asked to do to predict. So for a double replacement reaction, okay, so the way this might be written up is you have a solution of sodium carbonate, which is mixed with a solution of calcium chloride. And you're going to be asked to predict, or we'll say write, a net ionic equation based on predicting the results of this. So one of the things that we can tell here is because we have the word solution and solution, that automatically tells us those two are soluble. So let's write the sodium carbonate formula. And because it says solution, that means it's aqueous. And you should also recognize it has an alkali metal in it, and that makes it soluble. Calcium chloride, also going to be aqueous, going to be soluble. It's got a chloride in it. But if we don't remember that, it still says solution. Now, this type of reaction is going to be a double replacement reaction, where we're going to take the two metals and we're going to crisscross the charges, or we're going to switch them and then re-crisscross the charges to write new formulas. So we're going to make the sodium go with the chlorine, and sodium has a 1 plus charge, if you remember, and chlorine's a 1 minus, and so we crisscross them and don't write it. And then we're going to take the calcium and go with the carbonate. Calcium's a 2 plus, carbonate's a 2 minus. Sorry about the interruptions there. Now, our job is to predict who is the solid here, if there is a solid at all. We know that sodium is an alkali metal. It's going to be soluble, so we're going to make this aqueous. We predict carbonate with calcium is going to be insoluble, so this is going to be our solid. So now we've just formed a solid. Now the easy way to do a net ionic equation is we could ionize everybody and then cross out our spectators, or we could just take our solid down here, calcium carbonate solid. This is our shortcut. And we're going to work this guy backwards and break it up into its ions backwards. 2 plus aqueous plus carbonate, 2 minus aqueous. And we've just written our net ionic equation. Just like that, just by taking the solid backwards. Now that doesn't always work, but in double replacement reactions with two aqueous solutions, it does work. Okay? Spectator ions are going to be whoever's left, and in this case, it's going to be our sodium ion plus our chloride ion. And that's tonight's lesson on soluble versus insoluble. We'll do some practice on this tomorrow in class, and I hope you have a nice evening.